Hello, in this video, I'll take you through some basic Siemens PLC configurations, tag definition, best practices. And this is building up on our last video, where we did Siemens PLC configuration. If you've not seen that, I'll link that up in the description to this video. Please make sure you see that. So right here, I have a Siemens S7 1200 PLC. I have a network switch, a scaling switch, and a remote I/O device, which we've already downloaded to our physical hardware PLCs and devices. Again, if you've not seen that, please look at it. So right here, I want to discuss some very important things that would help you in your programming, which will be our next topic. So I wanted to take this very short video to give you that explanation. First, I would like us to go to our tag definitions inside our device configuration. While we were configuring our PLC, there were some settings that I informed you about. If you go, usually this is where we did most of the work in our general. Right now, if you go on this tab, I/O tags, you will see some things here that are called tags. So these are basically the names of the addresses, input, output, memory addresses, all other kind of addresses, which we would still discuss later, that are already in the PLC. The ones that are showing here are the memory devices which we activated. Let me show that to you. When we clicked on system and clock memory here, we activated this, enabled the use of system memory byte, enabled the use of clock memory byte. And as you can see, those gave us these addresses, which are by default in this case, and we left it at default. If you want to change that, you can change the address numbers, but usually just leave it at default. Enabling that gives us these addresses. We'll also discuss this later. However, the PLC has its own analog input card, which are these two addresses. They are integers, by the way. You can see type. This type shows the type of the signal type, the data type. These are analog input signals, they are in integers. And then we have the booleans, the digital input, I, and the digital output. So we have 6 input, 4 output. Here it shows the tag table, where these tags are located, where you place them in the PLC. Currently, they are just floating. They're not anywhere. And these are some of the things that I usually do before I start programming, because this really helps your programming a lot. So what do you do? First, if you expand your PLC folder, you would see something called PLC tags, and you will see PLC data types. Today, we're not talking about PLC data types. We're talking about the PLC tags. Here we have a default tag table, which is the table that the PLC itself has created, because of course it needs to place some of these tags into a table. If you click on this and open it, you will already see some tags there, which were the ones I showed you earlier inside the PLC. We also have some tabs here, user constants, which you can create, and then we have system constants. If you look into the system constants, you would see some names from those ports, those networking ports that we named when we're configuring the hardware. Here we see the network switch, the PN port 1, 2, 3, 4, 5, 6, 7, 8. We see the remote I/O PN port 1 and 2, and then we see the analog input, analog output. You can see their own data type and the values, the number inside the PLC. Now, you can begin to see why naming these things really helps you in your programming. Because if you look at this table, you can already identify which physical hardware this tag table, these names are located to. For the PLC itself, if you look at the X1 port, it's here, X1 port 1 is here. So if you have some higher programmings to do, which you would need to program the ports themselves, you can directly see the names. You already know what they are because you've named them. However, today we'll be talking strictly about tags here. So we have a default tag table, right? And now I want us to create some tag tables. So we'll go back into our hardware. And as I showed you earlier, these tags are already on this default tag table. We have some input and output. So usually what I do is I create a new tag table. If you double click on that, it creates one, and then we can change the name. So I can say PLC tag table. So all the signals, all the physical tags that belongs to the PLC, I want to put them on this PLC tag table. It shows 0 because I have not linked any tag to it. This is 67 because there are 67 tags currently on this default tag table. So right here, what I do is there is this input analog tag. I can just say PLC AI 1, or now I can already say analog, just to give it a name, right? Analog input 1. Now it automatically adds it to the default tag table, but right now I can pick on this drop down to pick the PLC tag table itself, which I've created. If I do a drop down on this, it automatically creates the next one. It's just like an Excel table and adds it to this PLC tag table. I'll quickly do the same for the digital input IOs as well. Digital input 1, and I want it on the PLC tag table. I'll do the same for the output, digital output 1. So we have all our input and output on the PLC tag table, right? And because this clock memory also belongs to the PLC, I want to put them on the PLC. So I can change PLC tag table. So I'm removing this address, this tag from this default tag table, and I want to put it on the tag table that I created. You can also do that. It says overwrite, then we click on OK. So it moves all these tags into my PLC tag table. And now when we look at this tag table, this has reduced to 53 and this has increased to 26. If I open this tag table now, I will find all these tags inside of this place. See, I can also add comments directly from here or now from the tag table. I can add comments. I can add comments here as well, however you want. Now, we also have input and output cards on the remote I/O station, the ET200SP device. And this is where what we're actually doing now really matters. This is where we actually need to put them in a tag table because we have input and output signals and addresses here, and you will be programming these a lot. So usually I'll create another tag table and then I'll call this ones so I can say ET200SP tag table. So I know that any signal that belongs to that comes from this module will stay on this my tag table. First, I will work on the analog input card up until the digital output. So first, analog So usually this could be anything. It could be a sensor, it can be whatever. But for the purpose of this training, I'll just give it a comment. Analog input from the T200 SP model. Analog input 1. I'll go ahead to do the rest now. I'm working on the last card now, which is the digital output card. So now, as you can see on the analog input, we have all the analog inputs, tag table, ET200 SP, the comments, analog output as well, same tag table and the comment, digital input, same tag table, the comment, and digital output, same tag table, the comments. Now, if we go into the ET200 SP tag table, we can clearly see everything all together. They're all here. Analog input, analog output, digital input, digital output. If you have a large project, you might not be able to do this one by one, just like I've done now. You can always import them using some specific tools. You can import tags using Excel. You can use CSV. I can make another video on that, which makes it easy for you. So when you look into your project now, you can already see all your tag tables, all your tags from different locations. So if you have different input and output, different locations, you can break them all down. However, if you want to see everything all together, then you can go to show all tags, which will show you everything inside this PLC. The PLC tag table tags, the ET200 SP tag table. If you have all other tag tables, everything will show up here because you can directly monitor the status of all of this directly from in here. You can also create some user constants which you might need to use later in your project. And again, like we said, you have your system constants that are here. So these ones are based on the hardware configurations that we've done. Now that we have all the tag tables all showing all together, you can now begin to program, which makes it very easy because you know the name of the tags, you know where it's coming from. For example, this is analog input 1, which comes from the PLC tag table. You know this comes from the PLC itself. You can, of course, we're currently using the default addresses, which the PLC itself has created. You can also change that if you go into the hardware of the PLC. So you can always change these addresses from the configuration where we have the input and output here. So the addresses, let me general, yes, IO addresses, yes. So it's currently starting from 64, and that is what you see on this input tags here for the PLC. Input word 64. Because it's an integer, it takes a double word. So it takes 64 and 65. The next address takes 66. You can change that here, and then that would change directly inside the program. But we want to leave everything by default. You can also change the ones on the ET200 SP modules. Same process. If you go to inside in the module itself, for example, analog inputs. Yes. So if you go into channel 0, hold on, general AI configuration, IO tags. Yes. Let me show where we can change this. Yes, IO addresses. Yes. So here you have 68. It starts at 68 because we have four analog input addresses here. The first one is 68, 69. The second one is 70, 71. The third one is 72, 73, and then the last one is 74, 75. That's why it starts at 68 and ends on 65 because it's double word. So that's what I want to show you here. Basically, when this is done, of course, you go to the PLC, you do compile. What we've done is software changes. So you can do software rebuild all. It rebuilds all your software. Because we also need to do some little programming in the next video, I'll just quickly create a data block. So right here, the only block we have here is the OB1, organization block 1, which does not have any programming in it yet. The tags that we have worked on are tags that belong to the PLC, the hardware tags. We want to create a software tag. So I'll go to the program, add a new block. So I can say add a new block. And what I want to add is a data block. So I can just say test DB. It's a global data block. I have not created any type yet. So I'll click on DB. You can give it any title, testing data block, and then you click on OK. We have some default data types inside the PLC that already exist. We'll talk about that later, but you can also add your own data type. So first, I just want to use booleans and integers. So I can say data, no, let me just use bool1, and the data type is boolean. I want 5 of this. So I'll say bool2, or I can just, I actually want to use them as import 1. I'll drag it up here. Yes, overwrite. I want here to be output 1, also boolean. Yes, boolean. Now I want to add some analog data. So for example, let me say temperature, or for now I'll just leave it as analog input 1. This is not boolean, this is integer. We have different data types like I mentioned. You have boolean, bytes. We'll discuss all of this later. Analog input 1, I want to create 5 of this as well, and then analog output, which are also integer. Yes, so for now, that's all I want to do. I need to compile all of this now because I've created a new DB. I've created some new things. So it says the test DB has now been successfully compiled. There are 0 errors, 0 warnings. Compile everything once again and save. So we're not downloading yet. I just wanted to show you all of that. Creating tags, default tags, tags that are specific to specific hardwares, tags that are from the DB. If we go into show all tags now, yes. So again, you can see all the tags from the ETSP module. You can see all the tags that are in the PLC tables themselves. If you also go into the DB, you can also see all the tags that you've created currently. So thank you very much and see you in the next video.